let's now, in our discussion of experimental design and data collection, let's start talking about one of the most simplest of all data collection or sampling schemes, that being a simple random sample. Now, a simple random sample is a random sample selected in such a way that every possible sample of size n in the population has equal probability of being chosen. Now, let's talk about some notation here real quick. When we use the lowercase n, we're talking about the sample size. That's how big of a sample we're going to take. When you see a capital N, this is making reference to the population size. So capital N makes reference to how big our population is. It could be several hundred thousand, a couple million, only 82, who knows. And then our sample, little n, is the sample size, how big of a sample we're going to actually take from that sample, or from that population. Now, lottery sampling is the very common, a very typical sort of a simple random sample. Suppose you have 6 numbers you're going to choose out of 1 through 54, 6 out of 54. The idea here is that there are many, many possible different groups of 6 that you could actually take out of that 54. Suppose we had, think of 54 people in a room, and every number's off. Okay, you're number 1, 2, 3, 4, 5, 6, all the way to the end there, you're number 54. It's possible on a simple random sample that I could pick number 1 through 6. That could happen. I could also have 1, 13, 27, 42, 51, and 36. I think that's 6 numbers. Okay, let's say it is. That's another possibility. If you think about the different ways you can combine 6 people out of 54, there's a bunch. So the idea behind simple random sampling is that each and every possible group of size little n, in the lottery sample of 6 and 54, 6 out of 54, little n would be 6, capital N would be 54. We want equal probability that each possible grouping of n, 6 in this case, has equal probability of being chosen. Now, how do we do that? Well, the easiest way for us to do that is to use some type of technology to do it for us. What we don't want to do is go, pick random numbers out of your head. That's typically not very random. The tendency is if you tell people pick 6 numbers out of 54, the tendency is kind of to group in the middle. So we want to avoid that sort of a thing. Let technology do it for you. For us in this class, or this course, we'll be using our TI-83 or 84 calculators. It does a pretty nice job of generating random numbers for us. So let's go ahead and step over and take a look at an 83, and I'm going to show you how you generate 6 random numbers between 1 and 54 for this lottery example. Okay, on your calculator, look down on the left-hand side, and you see a button that says Math. Push it, or select it, and then move up to the arrow pads. You see an up arrow, down arrow, left and right arrow. Move the right arrow over until, see right now Math is highlighted. We want to move it over into PRB is highlighted. PRB stands for probability. Option 5 says rand int. So that stands for random integer. And that's what we're talking about here. We're talking about integers between 1 and 54. So I want to select option 5. Now I can do that simply by pressing the 5 key, or I can down arrow until 5 is selected, or I'm sorry, highlighted, and then hit enter. When we do, we're going to see the command randint, standing for random integer, pasted to what's known as the home screen on your calculator. The calculator is now saying, all right, give me the parameters. Well, the parameters are going to be the smallest number that's possible to be chosen, the biggest number that's possible to be chosen, and how many you want to be chosen. In addition, or optionally, you can add to that information where you want these numbers stored, if you want to store it for future use. Well, in this example, what's the smallest number? So 1. Now I'm going to press the comma, which is right above the 7 key. What's the biggest? 54. Again, comma. And how many do I want? Well, we want 6. However, the calculator samples with what's known as sampling with replacement. In other words, if it happens to pick the number 7, guess what? It can pick the number 7 again. It puts 7 back into the pool of possible numbers. Well, we will do a sampling without replacement. A lottery sampling is sampling without replacement. If you pick the 7, it's not going to be picked again. There can only be one 7. So, because the calculator does not have that capability, I'm going to tell the calculator to pick more than 6. I'm going to tell it to pick, how about 10? That should be safe. And then hit the parentheses. Now what's going to happen is when I look through the 10 numbers that it's going to generate for me, I'll simply pick the first 6 that don't repeat. So if I get a 7, 9, 2, 7, I just delete that second 7 and use only the first one. Also, this is not required, but I'm also going to tell the calculator to store these in a list for me. Our calculator has list 1 through list 6 built in, L1 through L6. So I'm going to hit the STO key. If you look down your lower left, you'll see a key that says STO, that stands for store. If I press it, I'll get an arrow. And now I need to tell it where to store it. Well, I'm going to put it in list 1. If you look above the number 1 key, if you have a TI-83, you will see in yellow it says L1. If you have an 84, it'll be blue. In the upper left, you see the second key. That's the same color as your L1. In an 83, it's going to be yellow, and an 84, it's going to be blue. The second key is like a shift. So if I hit second 1, the calculator is going to paste L, a capital L, and a small 1 in there. That's telling the calculator list 1. Let me zoom in a little bit to make sure you can see what's on my calculator at this point. Okay, if you're following along, your calculator should look just like mine. When I hit enter, it's going to generate some random numbers, 51, 53, and you, of course, should have those same numbers. No, actually, you shouldn't. That was actually a statistical joke. That should be funny. It's random data. I have 51 and 53, the first one coming up. You may or may not have anything in the 50s. It's random data, or random number, so Lord knows what you're going to actually get. Now, on my calculator, you notice I have these decimals, 0.0000. The reason I have it set out to 4 places is because in my class, I have every report out to 4 places when working with decimals. These are integers. I could have very easily just set my calculator to only report 2 numbers rather than, no numbers to the right of the decimal rather than 4. They're integers, they're going to be all zeros, but it doesn't really matter. If I have my right arrow key now, I'll see my next numbers of 53, 25, 19, 53. See, I repeated 53, so I would delete this one. 16, 24, and so forth. Now, remember I said I stored this in a list. Let me zoom out just a little bit for you here. If I press the Stat key, it's in the center toward the top. Option 1 says Edit. That's the editor. If I press the 1 key or simply hit Enter, it's going to go to the editor. There's L1. There's the numbers that I generated. So see, I can go see 51, 53. 53 is repeated, so if I hit the DEL key, the delete key, that'll kill that 53. It's gone. Now I can take the first 6 numbers. See, 1, 2, 3, 4, 5, 6. Do I have any repeats? No, I don't. So 51, 53, 25, 19, 16, 24, those are the 6 random numbers that I would take from my calculator as a random sample, a simple random sample of 6 from 54. Now, one issue that could very easily happen with simple random sampling is these numbers could be grouped. I could have had a situation, like I mentioned earlier, I could have had 1 through 6 in there. Or I could have had all 50s or all 50s and 40s and ignored everything else. Well, when it's a lottery sampling, it's probably, in numbers, like the California lottery or something, it's probably not all that important. It's not an issue whether it's really clumped together or not. But if these are people, you could have clumps together in a room of people the same age, maybe gender, perhaps ethnic groups or athletes will sit together. There could be different groupings inside of a room that if you did a simple random sample and end up with numbers that were clumped together, you'd be ignoring these groups, which would result in a bad sample. You'd end up with a sample that's not very well representative of the population. So there are cases where a simple random sample is a bad idea. When grouping together of numbers could result in a problem, you probably want to avoid the simple random samples. That would bring us actually up to our next section we're going to talk about is a systematic 1 in K random sample. The nice thing about the systematic 1 in K is if you have a list, the 1 in K will prevent the numbers from being all grouped together someplace. It actually forces your sample to be spread out throughout the entire list. So we'll take a look at that in the next video.